In this video, you will learn how to solve and simplify different logarithmic equations and expressions. And in order to do so, you will use the logarithmic properties, or the properties of logarithm, which is also called the rules of logarithms, which are derived from the exponent rules. So let's know the parts of logarithm first and its properties. So let's take note of the parts of logarithm here. So to read this, logarithm of n to the base b equals x. So n here is our argument, b here is our base, and x here is our exponent, or our answer. So and this implies to this b to the x equals n. So our base would become would also be the base here, and then our answer would become the exponent, this one, and then our argument would become the answer. So we can write this one, this logarithmic equation, into this exponential form or equation. Now let's discuss the properties of logarithms that we use to solve logarithmic equations and logarithmic expressions. Okay, here are some properties. So the logarithm of 1 to the base a equals 0. You can write this as a to the 0 equals 1. So any number or variable raised to the power of 0 is equal to 1. Then the logarithm of a to the base a equals 1, and we can write this as a to the 1 equals a. Then a to the power of the logarithm of x to the base a is just equal to x, and some other properties. Okay, we have the product property. So the logarithm of m times n to the base a is just equivalent to the logarithm of m to the base a plus logarithm of n to the base a. And then we have the quotient property. Logarithm of m over n to the base a is just equal to the logarithm of m to the base a minus logarithm of n to the base a. And then we have the power property. Logarithm of m to the power of n to the base a is just equivalent to n logarithm of m to the base a. And then we have the change of base property. So logarithm of a to the base b is just equivalent to the logarithm of a to the base c over the logarithm of b to the base c. So those are the important properties of logarithm that you need to take note of. Okay, let's try solving some problems here. So let's solve this. We're given logarithm of 5x equals logarithm of 2x plus 9. So in this case, we can use the equality rule of logarithm, which says that if you have two logarithms with the same base that are equivalent, then we can just equate what is inside the logarithms, or what is inside the logarithms are equivalent to each other. So we can just equate 5x and then 2x plus 9. Now we can solve for x. We subtract 2x from both sides. Then we have 3x here. 5x minus 2x is 3x equals 9. Then we divide both sides by 3. Therefore, x is equal to 3. So this is the answer here. Okay, let's solve another problem. Negative 10 plus the logarithm of n plus 3 to the base 3 equals negative 10. And we solve for n here. Okay, we just have to add 10 to both sides. Okay, this is 0 and this is 0. Then we'll be left with logarithm of n plus 3 to the base 3 equals 0. And now we can apply one of the properties of logarithms. We can write this as 3 to the 0 equals n plus 3. And any number raised to the power of 0 is just equal to 1. So 3 to the 0 is equal to 1 equals n plus 3. Then we subtract 3 from both sides. And then we get 1 minus 3 equals negative 2 equals n. Therefore, n here is just equal to negative 2. Okay, let's solve another one. Okay, we have here negative 2 logarithm of 7x to the base 5 equals 2. So we just have to divide both sides by negative 2. Then we'll be left with logarithm of 7x to the base 5 equals negative 1. 2 divided by negative 2 is just negative 1. And now we can write this as 5 to the negative 1 equals 7x times 1 over 7. So this would give us x equals 1 over 35. So this is the value for our x. Okay, let's try another problem here. Okay, the logarithm of x minus the logarithm of 2 equals 1. Okay, to solve for x here, we can write logarithm of x minus logarithm of 2 using the quotient property. Since the base here is not given, so that means we're dealing with a common logarithm which has a base of 10. So we can write this as the logarithm of x over 2 equals 1. Of course, this is to the base 10. Then we can write this as 10 to the 1 equals x over 2. So this is 10 here. Then we multiply both sides by 2. This would be 20. So the value of x here is equal to 20. Okay, let's solve another one. Okay, ln of 2 minus ln of 3x plus 2 equals 1. So ln here means that we're dealing with a natural logarithm. So the definition of a natural logarithm is that, okay, when e to the y equals x, then the base e logarithm of x is just ln of x is equal to the logarithm of x to the base e equals y. So our e here, this e here is a constant, and this is called as Euler's number. And e has a value of approximately equal to 2.7182818 Now let's discuss some natural logarithm rules and properties. Okay, so we have the product rule. So ln of x times y, you can write this as ln of x plus ln of y. Then the quotient rule, ln of x over y is just equal to ln of x minus ln of y. And then we have the power rule, ln of x to the y can be written as y times ln of x. Okay, ln of 0 is undefined. ln of 1 is equal to 0. Okay, that's all for the natural logarithm rules and properties that you need to consider of. We will not discuss the properties and rules in derivative and integral. Okay, so let's solve this problem here. Okay, to solve this problem here, we can use the quotient rule. So ln of 2 minus ln of 3x plus 2 can be written as ln of 2 over 3x plus 2 equals 1. Now we can write this as the base e logarithm of this one, 2 over 3x plus 2. So we can write this as logarithm of 2 over 3x plus 2 to the base e equals 1. And then using the properties of logarithm, we can write this as e to the 1 equals 2 over 3x plus 2. And now we can solve for for x. So we multiply both sides by 3x plus 2. This would become e times 3x plus 2 equals 2. Then we distribute e here. So we have 3ex plus 2e equals 2. Then we subtract 2e from both sides. Then we have 3ex equals 2 minus 2e. Then we divide both sides by 3e. So x would just be equal to 2 minus 2e over 3e. Or you can write this as 2 over 3e minus 2e over 3e, and e here cancels out. Therefore, our answer would be x equals 2 over 3e minus 2/3. So this is the value for our x.